Welcome to our presentation on multi-factor authentication, MFA, and cloud identity and access management, IAM. Today, we will explore the importance of robust security practices in the digital age, focusing on integrating MFA with Okta and Active Directory, as well as understanding the essentials of IAM in AWS and Google Cloud. This presentation will equip you with knowledge on these critical security mechanisms and their practical applications, underpinning your journey towards enhanced cyber resilience. We will navigate through the following key areas. 1. Introduction to multi-factor authentication. MFA will begin by understanding the concept of MFA, a method of confirming a user's identity only after presenting two or more pieces of evidence, or factors. This process significantly enhances the security of user logins and protects against threats like phishing and credential exploitation. 2. MFA integration with Okta and Active Directory. Next, we'll focus on how MFA integrates with Okta and Active Directory. With Okta, we'll look at its flexibility, enhanced security, and adaptive capabilities. Then, with Active Directory, we'll examine how it bolsters the security of network resources, especially against cyber threats. 3. Introduction to identity and access management, IAM. Transitioning from MFA, we will introduce IAM, an essential element in cloud security that helps manage access to resources securely. IAM revolves around who can do what. 4. Overview of AWS IAM and Google Cloud IAM. We'll delve into the specifics of AWS IAM, discussing its policies and how they control access to AWS services. Next, we'll discuss Google Cloud IAM, showcasing its capabilities and drawing comparisons and contrasts with AWS IAM. We'll highlight how both IAM services are crucial in maintaining secure and controlled access to their respective cloud resources. Multi-factor authentication, often referred to as MFA, is an essential element of comprehensive cybersecurity. It is a method that requires users to provide multiple forms of verification to prove their identity before gaining access to a particular system or application. This process significantly increases the security of user logins, adding an additional layer of defense against unauthorized access or breaches. MFA works on a simple principle: to use two or more separate categories of credentials to validate the user's identity. These categories typically fall into three types: something you know, like a password or PIN, something you have, like a smart card or mobile device, and something you are, like a biometric characteristic, such as a fingerprint or voice pattern. The primary advantage of using MFA is that it provides increased security. If one factor is compromised, such as a password, the attacker still has at least one more barrier to breach. This significantly reduces the likelihood of successful cyber attacks, including phishing, keylogging, or password cracking. In today's digital world, where cyber threats are continually evolving, implementing MFA is not just beneficial but critical. It serves as a powerful tool that protects not only the user's credentials but also the resources and data that the user can access. Thus, MFA has become a cornerstone of a robust security posture, contributing to the defense-in-depth strategy. Okta is a leading identity and access management (IAM) platform that enables secure access to technology and applications. One of its critical features is multi-factor authentication (MFA), which enhances security by requiring users to present two or more separate forms of identification before granting access. MFA in Okta involves integrating it into your existing applications, both on-premises and cloud-based. It supports various factors, such as security questions, SMS, voice call, email, Okta Verify, mobile app, and physical or software-based tokens, offering flexibility and enhanced security. Here is an overview of the Okta MFA integration process. 1. Enrollment and activation. After setting up MFA, users are prompted to enroll their secondary authentication method during their next sign-in. After enrolling, the user is activated and ready to use MFA. 2. Configuring factors. Okta allows admins to set which factors are allowed for their users. This is done via the admin console, allowing you to enable, disable, and configure the settings for each factor. 3. Policy configuration. Policies control who must use MFA and when. For instance, you could require MFA for all users, only certain groups, or based on network or location. Policies are configured in the admin console. 4. Adaptive MFA. This advanced feature uses machine learning algorithms to determine the risk level of a login attempt and adjust authentication requirements accordingly. It can prompt for additional factors when risk is detected, such as unrecognized devices or unusual locations. 5. Application integration. Okta provides SDKs and APIs to integrate MFA into your applications. This can be done in different ways, depending on the application type, web, mobile, or single-page application. 6. Third-party integration. Okta also integrates with third-party MFA providers, such as Google Authenticator, YubiKey, RSA Secure ID, and Duo Security. 7. Reporting and audit. Okta's reporting features provide valuable insights into your MFA setup. Reports include information on successful and failed authentication attempts, factor enrollment, user behavior, and more. 8. End-user experience. Users experience a seamless, easy-to-use MFA process. After entering their primary credentials, they are prompted for their secondary factor. Okta's flexible MFA options ensure a balance between security and user experience. To sum up, Okta's MFA is a comprehensive, flexible, and secure solution for managing access to applications. Its wide variety of supported factors, integration options, and adaptive capabilities provide a robust and user-friendly approach to identity and access management. While implementing MFA with Okta requires careful planning and configuration, the enhanced security it provides is well worth the effort. Active Directory (AD) is a Microsoft technology used to manage and store information about network resources, notably user account details, on a network. Multi-factor authentication (MFA) is a security method that requires the user to provide 2 or more verification factors to gain access to a resource, enhancing protection against unauthorized access. When you integrate MFA with Active Directory, it significantly boosts the security of user logins for all network resources, particularly against threats like phishing, ransomware, and credential exploitation. 1. Enrollment and activation. Upon MFA setup, users are required to enroll their secondary authentication method during their next login. After the enrollment is successful, MFA is activated for the user. 2. Configuring factors. Microsoft MFA, part of Azure Active Directory, supports various factors: phone call, text message, mobile app notification, mobile app code, and hardware tokens. 3. Policy configuration. With conditional access policies in Azure AD, you can determine under what circumstances MFA is required. You can set it based on user role, location, device state, application sensitivity, or even real-time risk detection. 4. Azure AD Identity Protection. This uses machine learning algorithms to identify suspicious actions related to your network's identities. If it identifies a risk, such as impossible travel or unfamiliar sign-in properties, it can trigger MFA requests. 5. Application integration. Azure AD can be integrated with thousands of SaaS applications, ensuring MFA protection extends to all your critical resources. 6. On-premises integration. Azure MFA can be integrated with your on-premises AD using Azure MFA Server or through AD Federation services. This means you can protect your on-premises applications and resources with the same MFA solution. 7. Third-party integration. Microsoft's MFA solution can integrate with third-party solutions via standard protocols like SAML and OAuth. 8. Reporting and audit. Azure AD provides detailed reports about user sign-in activities, MFA results, potentially risky behaviors, and more. This data can be used for compliance, audit, and troubleshooting purposes. 9. End-user experience. With Microsoft Authenticator app, users get a smooth MFA experience. They approve a notification on their smartphone after entering their regular password. If the phone isn't available, users have alternative methods like a phone call or SMS. In summary, integrating MFA with Active Directory, particularly when leveraging the power of Azure AD, offers robust protection for your network resources. It enables you to define flexible policies, use a variety of factors, and monitor activity for anomalies, creating a strong security posture against cyber threats. Identity and Access Management, IAM, is a crucial aspect of information security, providing the tools and infrastructure necessary to control user access to critical information within an organization. At its core, IAM is about ensuring that the right people have the right access to the right resources in the right context. IAM revolves around three central components. 1. Users. These are the individuals or services that need access to resources. Users can be employees needing access to applications, customers logging into a web portal, or services requiring access to data. 2. Authentication. This process confirms the identity of the user or service. It often involves the use of credentials, like usernames and passwords, or more complex methods like multi-factor authentication, MFA. 3. Authorization. After confirming identity, IAM systems determine what actions the authenticated user or service can perform. Based on predefined roles and permissions, it checks what data they can access and what operations they can perform. IAM solutions are essential in today's security landscape, especially for organizations moving resources to the cloud. They allow businesses to offer the right individuals the appropriate access to technology resources. From enabling a new employee to access a specific group of applications, to allowing a developer to spin up a test environment in a cloud platform, to letting a customer view their account details on a web portal, IAM solutions make these scenarios possible in a secure, controlled manner. The implementation of IAM offers significant benefits, including improved security, lower help desk costs, streamlined IT processes, and enhanced user experiences. By deploying an effective IAM strategy, organizations can tackle security and usability challenges, creating a safe and productive digital environment. AWS Identity and Access Management, IAM, is a web service that helps you securely control access to AWS resources for your users. It allows you to manage users, security credentials, and permissions that dictate who is allowed to access which resources. IAM policies are the primary method to set permissions in AWS. A policy is an entity that, when attached to an identity or resource, defines their permissions. AWS evaluates these policies when a principal, such as a user, makes a request. Here is an overview of IAM policies. 1. Types of policies. Identity-based policies. These are attached to IAM identities, users, groups, or roles. They grant permissions to a principal. Resource-based policies. These are attached to resources like S3 buckets or Lambda functions. They grant permissions to a principal, which can be in the same account or another account, to access the resource to which it's attached. Permissions boundaries. This is an advanced feature for delegating permissions management to other users. A permissions boundary controls the maximum permissions a user can have. Service control policies, SCPs. These are used in AWS organizations to set fine-grained permissions for accounts. Access control lists, ACLS. These control which principals in another AWS account can access a resource. Session policies. These control permissions for a session, limiting the permissions that a role or user's credentials can grant to applications. 2. Policy syntax. AWS IAM policies are expressed in JSON format and include elements such as version, statement, effect, allow, deny, action, resource, and condition. 3. Evaluation logic. When a request is made, AWS uses request information to assess policies. The default is an explicit deny, and an explicit allow overrides this. However, an explicit deny in any policy overrides any allows. 4. AWS managed policies. These are pre-built by AWS and cover common use cases like read-only access to S3. 5. Customer managed policies. Users create these to meet the specific access control needs of their organization. 6. Policy simulation. The IAM policy simulator allows you to test the effects of your policies before committing them, reducing the chance of unforeseen access issues. By managing permissions through IAM policies, you can adhere to the principle of least privilege, giving users and resources the minimum access necessary to perform their jobs, thereby enhancing your AWS environment's security. Google Cloud Platform, GCP, provides a similar service to AWS IAM known as Google Cloud Identity and Access Management, IAM. It allows administrators to manage access control by defining who, identity, has what access, role, for which resource. Below are some key features of Google Cloud IAM. 1. Identities. This is the who part of IAM. An identity can be a Google account for end users, a service account for apps and virtual machines, a Google group, a Google Workspace domain, or a cloud identity domain. 2. Roles. A role is a collection of permissions. Permissions determine what operations are allowed on a resource. Predefined roles are provided by Google, or you can create custom roles. 3. Resources. This is the what part of IAM. A resource can be a Google Cloud service like a compute engine VM, a cloud storage bucket, or a pub subtopic. 4. Policies. Policies bind identities to roles. A policy is a JSON object containing bindings, and each binding binds one or more identities to one or more roles. 5. IAM conditions. You can specify conditions in IAM policies to grant access based on attributes of the request, like IP address or resource name. This allows for finer-grained access control. 6. Service accounts. Service accounts are special accounts that represent a non-human user, such as an app or a VM instance. These accounts can be granted permissions using IAM roles. 7. Audit logs. Google Cloud IAM maintains audit logs for each project and organization, providing visibility into access control decisions and allowing for compliance, auditing, and analysis. 8. Principle of least privilege. POLP. Google Cloud IAM supports POLP, ensuring that identities have only the minimal access they need to perform their tasks. Just as with AWS IAM, Google Cloud IAM is essential for maintaining secure and controlled access to GCP resources. It provides a unified view into security policy across an organization, simplifying management and reducing risk. In conclusion, we've explored the vital role that both multi-factor authentication and identity and access management play in modern cybersecurity. We've examined the integration of MFA with Okta and Active Directory and understood how they significantly fortify user authentication, offering a robust line of defense against cyber threats. Additionally, we've delved into the realm of AWS and Google Cloud IAM services, which help control who can access resources and how they can interact with them. IAM, with its principles of least privilege and explicit deny, allows us to securely manage resources, reducing the potential attack surface and mitigating potential damage. We live in an era where cybersecurity breaches have become both more frequent and more sophisticated. As a result, applying these multi-layered security approaches is no longer a luxury but a necessity. MFA makes it harder for attackers to gain access, and IAM ensures that they can't do much even if they do. Together, they form a potent combination that can significantly enhance the security posture of any organization. Today's overview is a step towards understanding these technologies and their importance in depth. But remember, security is not a one-time activity, it is a continuous process. Always keep your knowledge up to date, adapt to new threats, and continuously improve your security posture. Stay safe and secure in the digital world. Remember to invite questions and thank your audience for their time and attention.